This is the video for Accelerated Geometry 18-1, Graphs of Sine and Cosine. Today we're going to look at the characteristics of the graphs of sine and cosine curves that we should have looked at yesterday in class in the task that we did. So the first thing we're going to look at is a periodic function. A periodic function is a function that repeats in regular intervals called cycles. Both sine and cosine are considered periodic functions. The length of the cycle is called its period. So below I have two pictures for you. These are examples of periodic functions. The first one is considered a periodic function because if I take it and cut it and slide it over, I should be able to repeat or land on top of that same exact picture or piece of the picture. In this picture, if I were to cut it and slide it over, it would not land exactly on top of itself in the remaining part of the graph. So take a look at these two pictures. See if you can decide which one is periodic and which one is not. You might get stuck on this problem and want to think that the first one is periodic because you see a line of reflection. But again, it has nothing to do with a line of reflection. If we can take and cut the picture, slide it over, and it land exactly the same, then it is periodic. In picture 2, if we took and cut and slid it over, it would land exactly on top of itself. So number 2 is the periodic function. Now, yesterday in class, we talked about how to graph y equals sine x and y equals cosine x. Here's the picture of those parent graphs. Now, it is important to indicate the x-axis has a scale that increases by pi over 2 at each tick mark. So the first dash represents pi over 2, the second dash represents pi, the third dash represents 3 pi over 2, and the fourth dash represents 2 pi. We could keep going, and the next one would be 5 pi over 2, then 3 pi, and then 7 pi over 2, and 8 pi. But for right now, we're just looking at one period. Same thing for the cosine graph. It would be, the x-axis would be labeled the same exact way. Now, our y-axis is labeled by ones. So our highest value we get to on the parent graph is when when the y value is 1, and the lowest value would be when y equals -1. So one big difference we should notice between our parent graphs is how they start on the y-axis or when x is 0. Sine starts on the origin, whereas cosine x starts at 0, 1. So, it's important to note when we get to graphing that when we graph one period or one cycle for sine x, we're going to graph middle, high, middle, low, middle. So, again, that's middle, high, middle, low, middle. And so as we connect to those points, that creates our one period or one cycle of the sine graph. Notice it continues. We would go back up to the high, then back to the middle, back low, back middle. Same thing for the direction to the left. We would just continue that cycle, making our domain all real numbers because it continues both left and right. For cosine, it's a little bit different. We start high, then go to the middle, low, back to the middle, and then high to graph one period. Again, high, middle, low, middle, high. Then we'll go back to the middle, low, middle, high, and continue and so on. Again, that just graphs one period. And we'll use this a whole lot more tomorrow when we're actually graphing these functions. So our range would be from our lowest value for y to our highest value for y. For both these parent functions, our lowest y value is -1, and our highest y value is +1. So we can write it in interval notation using our cornered brackets. Another way to write that would be -1 is less than or equal to y is less than or equal to 1. Okay, now let's talk about transformations. When we take the parent graphs and add some different values in, that would cause a transformation within the coordinate plane. We've seen these letters before with each function that we've talked about transformations with. We know that A represents a vertical stretch or a vertical compression. With trig graphs, we call that the amplitude. B, we've talked about, represents the horizontal stretch or compression. With trig graphs, we call that the period. H, we talked about, allowed us to shift left or right, or a horizontal shift. So we call that phase shift with trig functions. And then the K out that moved us either up or down, our vertical shift. So, the first definition we have is the amplitude. The amplitude of sine and cosine is half the difference between the maximum and minimum values of the function. The amplitude is always the absolute value of A, because if we had a negative out front, remember that means a reflection over the x-axis. So the amplitude only comes from the absolute value. For the parent graphs, our amplitude is +1. Again, reason being, from the top, the maximum, or from the low, the minimum, the difference between those two is 2 units. Half of that represents the amplitude. Another way to think about that is from the middle up is 1 unit, and from the middle down is 1 unit. So our amplitude is +1 for both sine and cosine. The period is found by doing the length of one cycle of the graph. Our period of the parent graphs is from one beginning to the end of a complete cycle. So from beginning 0 to the end 2 pi, our length would be 2 pi. So our period is found by doing 2 pi divided by our b value. In our case, when we have y equals sine x or y equals cosine x, the b value is 1. So 2 pi divided by 1 leaves me with a parent graph having a period of 2 pi. The value in the parentheses with the x is called the phase shift, which shifts us either left or right horizontally. It's always opposite of what we think. Left would be plus, and right would be minus. And then the value outside the parentheses is the vertical shift, so it's going to send us up if it's positive and down if it's negative. Just like every function we've talked about so far this semester. Okay, so let's take a second and talk about the transformations of each of these graphs. We're going to identify the amplitude, period, phase shift, vertical shift, and domain and range. So our amplitude for this first graph comes from A. So if we take a look at this graph, 3 is our A value. So our amplitude is 3. Our period is found by doing 2 pi over b. Well, our b value isn't indicated, so we understand it's a 1. So to find our period, we would do 2 pi divided by 1, which is just 2 pi. Our phase shift comes from the parentheses. There's no parentheses, so there's no phase shift. Our vertical shift comes from the plus or minus out back. There is not any, so we have no vertical shift. Our domain for both sine and cosine is all real numbers. Now, our range in the parent graphs was from -1 to +1. But in this case, we have an amplitude. That means if I'm going to graph this trig function, from my middle I'm going to have to go up 3 units to get to the high, and I'm going to go down 3 units to get to my low. So when I graph this sine function, it's going to be taller than normal. So instead of being from -1 to +1, our range is going to be from -3 to +3. A way you can think through that without looking at it visually is to multiply by the amplitude. If we took our original range and multiplied by 3, that would give us our new range. All right, for number 4, our amplitude comes from A. A is 1. Our period comes from 2 pi over B. So we would set up 2 pi over, and in this case, our B value is 1/2. We can't leave a fraction within a fraction, so we say 2 pi times the reciprocal, which would be 2 pi times 2 over 1, which gives us 4 pi. Phase shift, there's no parentheses, so we have none, and there's no plus or minus out back, so there's no vertical shift. Our domain for these two functions is all real numbers. Our range is going to be affected by both the amplitude and the vertical shift. Since our amplitude is 1 this time, that makes our range stay from -1 to +1. All right, for number 5, our amplitude is going to be 1 from A. Our period is going to be 2 pi divided by 1, which just gives us 2 pi. Whoops, that's pi. Our phase shift, this time we do have parentheses. So opposite of what we would normally think, it would send us left pi. Vertical shift, no k out back, so we don't go up or down any. Our domain is all real numbers. Our range is affected by both the amplitude and the vertical shift. There's no vertical shift. Our amplitude is 1, so that keeps our range from -1 to +1. Okay, last example. The only value we have is k. So our amplitude is 1, our period is 2 pi, our phase shift is none, our vertical shift would be down 3. So our domain stays all reals. Our range, again, is affected by the amplitude and the vertical shift. Our original range is from -1 to +1. So we would multiply by our amplitude, doesn't cause it to change. But for our vertical shift, we're moving everything down 3 units. So in order to find our new range, we would subtract each of these numbers by 3 because it says move down 3. So our new range is not going to be from -1 to +1. It's going to be -1 minus 3, which is -4, and 1 minus 3, which is -2. That would be our range for this graph. All right, how about you take a second and you try these 4 on your own. So hit pause and try these 4. Okay, check in your answers for 7, 8, 9, and 10. For number 7, your amplitude is 2, your period 4 pi, no phase shift or vertical shift, our domain is all real, and our range is from -2 to +2 because we had an amplitude change. For number 8, our amplitude is 1/2, our period is 2 pi, our phase shift is none, our vertical shift is up 1. Our domain is all real numbers, and our range from our amplitude changed from -1/2 to +1/2, yet we also had a vertical shift up 1. So we had to add 1 to each of those, which leaves us at 1/2 to 3/2. For number 9 and 10, you can go ahead and check out what the answers are. Notice that the range for number 9 is from -1 to +1 because of our amplitude and our vertical shift. Our range for number 10 is from -7 to -3 because of our amplitude and our vertical shift.